and welcome back to Mr. Alawi. Hello, welcome back to Mr. Alawi. And I know I haven't posted over the summer because there it was not really anything to post. But now that we started the year, so we just started lesson one last week. So yeah, for those in basis, this is really like a big help. So today I'm just going to be explaining the homework because that basically has the important parts of the lesson. So, and it's just from number 12 to number 27, and here we go. So, for number 12, it's asking what happens on the graph when x equals 4. And the equation we get is y equals negative 1/2 x plus 2. And it says it is negative over the interval 4 and infinite, and positive over the interval negative infinite and 4. So for this, you can just plug in 4 and 4 for x here. So it would be y equals negative 1/2 times 4 plus 2. And negative 1/2 times 4 is just negative 2. So your new equation would just be y equals negative 2 plus 2. And you just get y equals 0. So that would be your answer, y equals 0 for number 12. For number 13 is one a student made a graph and like he made an error while like describing it. So and the error is where it shows the brackets for positive. So for the correct answer would have been for negative 1 and 3, it should be in parentheses right here, not in brackets, because brackets means it includes that. But parentheses means it doesn't, and it can't include it because you can't include anything on the border. So it has to be before it or after it. So in like this space or this space. So that's why it's incorrect. So it would be the correct answer, which is right here. It's negative 1 and 3 in parentheses. And for number 14, it's asking us to sketch a graph using these features. So it wants us to have the domain at negative 4 and 4. So you can just go ahead and put a point on it if you're graphing it. So just make a graph and put a point at negative 4 and a point at 4. So keep it at like 0. Keep it at 0, negative 4, or negative 4 and 0, and negative and 4 and 0. So we'll erase it and like fix it after. The range is negative 4 to 6. So it includes negative 6. So you put a point at, it includes 6. So the domain for negative 4 has to be at negative 4, negative 4. And then, the x-intercepts is what we start with. Negative 2 and 0. So we put a point at negative 2 and we put a point at 3. So it's as it says here, negative 2, 0, so right here, and 3, 0, so right here. We put a point there. Then it's asking, and then the y-intercept is 0 and is 0, 4. So you put a point right here at 0, 4. So you should have 3 points on your graph by now. 1 point at negative 2, 0, negative 2 being x and y equals 0, and then 3, 0, and then 0, 4. So remember, the left number is the x-axis and the right number is the y-axis. So next, what we do is we find the increasing portion. So that is from negative negative 4 to 1. And it is because as you can see here, it gets going up like this and then goes down at 1. So negative 4 there should be a point at negative 4, negative 4, and a point at 6 or 1, 6, because that is where it starts like increasing. So and then for the decrease, my camera's flipped, so you might see me doing it the opposite direction. but the decrease is from 1 to 4, because as you can see from the x-axis 1, this is 1, and then goes all the way down until 4 on the x-axis. So those should be your points. Now I should have more points. One at negative 4, 4, one at 1, 6, and then one at negative, and one at 4, negative 3. So next, let's so we did the x-intercepts, y-intercepts, increasing and decreasing, and we kind of already have the domain because it's from negative 4, as you can see here, to 4. And then the range is from on the bottom here, negative 4 to 6, the top here. So, and it doesn't include negative 4, but it does include 6. So now we'll go on to the negative part and the positive part. You should already have your graph by now. So it's just it's a just like a opposite V. It's a downwards V flipped. And these are the points you should have. The main points, which are the x-intercepts, the y-intercepts, the increasing and decreasing, and yeah, at that point, the domain and range in negative and positive are just already there. You don't really need to mark them. So this would be your answer for number 14. This would be the graph. For number 15, it's saying a student says that all linear functions are either increasing or decreasing. Do you agree? Explain. So a linear function is just a line on the graph. So it's just a line going this way or a line going this way. But that's what the student says the only thing it can be. So remember my camera is flipped. So a line going from the top left to bottom right, that would be a decreasing line. And a line from the bottom left to top right, that would be an increasing line. And the student's saying that's the only thing that is possible. But that would be incorrect because a line could be just straight horizontal or straight vertical. And the straight horizontal would just be constant, and straight like vertical, it would just be like you'll learn that it's like not really possible for a line to be vertical, because you can't be at like there can't be multiple y's for one x, but there can be multiple x's for one y. So that would be for number 15. Your answer for number 15 would be no, because a line can be either horizontal or vertical. So now going down to 16. A relative maximum of a function occurs at the highest point on a graph over a certain interval. A relative minimum of a function occurs at the lowest point on a graph over a certain interval. Explain how to identify a relative maximum and a relative minimum of a function using key features. So a relative maximum would just be, as we saw here, it's asking for an increase, it would be asking for like the increase. So it would just be the one going either relative maximum would be when it starts going down. So for like this graph, let's say this point up here, that would be the relative maximum, and then the lowest point, and then these lowest points would be the relative minimum, because this is the relative minimum, because that's when it starts increasing, and relative maximum is when it starts decreasing. So another example would be from here. This would be the relative minimum, because it starts increasing from here. And then when it starts decreasing, the top is the relative maximum, because then it starts decreasing down. So that would be your answer. A relative maximum is when it goes from decreasing to increasing, and a relative minimum is when it goes from decreasing to increasing. So that would be your answer for 16. Now for 17, for a graph of speed in miles per hour as a function of time, in hours, what does it mean when the function is increasing, and what does it mean when it's decreasing? This one's pretty easy. It's just when the function is increasing, speed is also increasing. And when the function is decreasing, the speed is also decreasing. So that would just be your answer. Now for number 18, we're going to be using this graph for to help us. So the domain and range. The domain is just the farthest to the farthest, the outermost to x just x coordinates. So for 18, the x is really any real number, because as you can see over here, if you see these arrows pointing like that way, it means it's infinite. It's like keeps on going. So for here, that means it would keep on going until x like equals negative infinity, because remember, this is the negative side, and then this would be positive infinity. So for this, and you can't really include infinity, so there's going to be parentheses. And in the parentheses, it would be first negative infinite and then positive infinite. So, which is like just this. The range is a little different though, because the minimum range here is -9, so it's not infinite, but the maximum is infinite because it keeps on going up and up and up because of these arrows. So for this, your answer would be in one bracket, -9, comma, and then positive infinite parentheses. So it'd be bracket, parentheses. And yeah, that would just be for 18, which it just shows here. For 19, it's asking for the x and y intercepts of the function. So that would just be when it like goes past the x-axis, and over here we can see that it goes past the x-axis at -4, 0. So that would be when it goes just -4, and then over here is 2, 0. So the x for x would be just -4 and 2. Because this is -4 here, it just crosses it, and then this is 2 here, it just crosses the axis. And for the y-intercept, when it crosses the y, and y is just the vertical one, and over here it's -8, because as you can see right here, that's at -8 is when it just crosses over. So that would be your answer. For y-intercept is -8, and for x-intercept it's -4 and 2. For 20, it's asking when is the function positive, and when is it negative. So for positive, it would just be like when is it like just above the x-axis, and like negative is just when it's below. So for the positive, it would just be negative infinite 4 to positive to 2 and to 2 infinite, because over here it just keeps on going and going and going, and that's just negative infinite, and it starts going there at -4. It's just from here, it's just from x-axis, the -4, all the way up, 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 infinitely to negative infinite. And for here, it was also another positive one would be from 2 to positive infinite, because it starts at 2 and then it goes up, 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 all the way to infinite. And for negative, it would just be from negative, it would just be -3 to, it would just be from -3, or sorry, -4 to 2, because that's the interval. It starts decreasing at -4 and also at -2, and it just connects. The reason we have 2 for positive is because those two never connect. They just keep on going the opposite direction infinitely. But for negative, it's a parabola. It like curves and connects. So that's why there's only one, which is -4, 2. And for the positive, there's negative infinite to -4, and 2 to to positive infinite. For for number 21, when it's increasing and when it's decreasing, it starts decreasing from negative infinite down to -1, because as you can see, that's where the vertex is. It's at -1 right here, and it starts all the way from up there, like infinitely, down, 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 decreasing until -1, and it starts increasing again all the way up from -1 to positive infinite, which would be your answer right here. Now this one is like a little tricky one. Took me a bit to like fully understand the rate of change. So it's just asking for like when -3, the point when it's like symmetrical to the y, and when 2 is symmetrical to the y. The formula for this is just FB minus FA over B minus A. FB is just what the y-axis is when it's on 2. So right now, 2, when it's over here, 2 is at 0, because it just crosses at 2 when it's 0, and that's where it's like symmetrical, vertically symmetrical, and or horizontally symmetrical. And over here for -3, which is A, it's like perfectly like symmetrical with -5. So that would be, so FA would be -5 and FB would be 0. So it would be 0 minus -5, which is just 0 plus 5, over B minus A. So it's just 2 minus -3, which is just 2 plus 3, which is 5. So it would be 5 over 5, which is 1. So the answer for 22 is just 1. For the domain, now we're going to the next one. So we're going to use this graph for 23 to 27. 23, the domain, the like farthest most x-axis or x coordinates. As you can see here, there's no arrows, there's just points. So it's not like going infinitely. So it's from -4 to 4, and that would be your -5, sorry, -5 to 5, and that would be your domain. And then for your range, it's just the lowest range to the lowest y coordinate to the highest. Right here, the lowest is -1, and the highest is 2, so it would just be -1, 2. And it includes them because there are points, so that's why there are brackets there, not parentheses. And now we're going to 25, or 24, sorry. And that's the x and y intercepts of the function. So when it intercepts at x, is at for x it intercepts at 3 and -5, because as you can see here, it's on the x-axis at -5, so it'd be the first intercept, x-intercept, and then over here it passes at -3, because that's 1, 2, 3, so it passes over here at 3. So the answer for that, for the x-intercepts, would just be -5 and 3. For the y-intercept, it's y-intercept is just when it crosses the y-axis, and you can see here it's in the middle between 1 and 2, so it'd be 1.5. And that would be just your answer over here. For 25, the function, when the function is positive or negative, so up here from -5 to 3 is positive because it's above the x-axis, and then from 3 to 5 is negative, and it includes 5 because it's a point. So yeah, that would just be your answer. That's an easy one. That's 25. And now 26, the function when it's increasing or decreasing, it's increasing from -5 all the way to -1. Because as you can see here, that's when it like stops and starts decreasing from -1 to 5. So your increasing would be -5, -1, and then decreasing would be -1 and 5. And now for the average rate of change over the interval -1, 5, kind of same one that we did over the other graph. So you just find -1, when it's on -1, it's going up. The y-axis for it is, the y-coordinate is 2. So this one is -1, 2. So FA, which is -1, A is -1 and B is 5. So FA, the function of A, which is the function of -1, is 2. So, and then the function of B, which is a function of 5, 5 is just at, the point is just at -1, because as you can see, it's just on the point. It's not going really up or down. So it's just on the point. So that would mean it's just going to -1, because that's exactly where it's symmetrical. So the FB would be -1, and FA would be 2. So just be -1 minus 2, and you get -3 for the top part. And then for the bottom part, B minus A, it would be 5 minus -1 minus -1, which is just 6. So -3 over 6, that would be -1/2, and that would be your answer right here. So, yeah, that's all the homework problems. If you have any questions, put it down in the comments. I'll respond to them as soon as I can. And yeah, thank you for watching, and I'll see you next time.